or you all can share screen. Let's see. Some people, Becky, Becky, this is your first Figure Friday session with us?
Yes, yeah.
Cool. Okay, perfect. Hey, Greg, welcome. Greg, you're mute. Let me see if I can unmute. I think I can unmute.
I got it.
There we go.
Hello, thank you. Good morning.
Morning. Where are you calling us from?
I'm in North Carolina.
North Carolina. Oh, are you close to Raleigh?
Not really.
Okay. We just set up a community member by the name of Tom. The Plotly community member has set up a Plotly data visualization of Raleigh, in Raleigh, obviously. That's going to happen on June 25th. We're going to be like about hopefully 5 to 10 people there working with Plotly and doing on the data visualization that is related to Raleigh. So that'll be cool.
Now I'm up in the mountains.
Okay, in the mountains as well. Cool. Hey, Mike, welcome. There we go.
Hello.
All right, folks. So as always, this is the Figure Friday session where we talk about all the graphs and data apps that were built for the previous or for this week's Figure Friday. This week we are in week 21. We're going to share a few screens here and a few applications or just graphs. And the idea is just to learn from each other, right? To share feedback, ask questions, provide feedback. Yeah, I think this part of the graph is great. I will maybe change the label here to say this because X, Y, and Z, whatever. The idea is to learn from each other. Sometimes people come and just observe, and that is completely fine. You can still give feedback if you're just observing or you just want to sit it out the first time and just watch. That's perfectly fine. If you have a graph or an app that you created, definitely feel free to share it with us. So I know who created here apps or graph? Who would like to show us some of what they built today?
I'm up for it.
Becky,
with it.
Perfect. Mike, and then Matt, are you going to show us something?
Of course, I realized I was muted at least. I can show something I've made before. I wasn't working on this data set this week.
Oh, okay.
I'm busy with the new work, where I'm working a lot with CO2 emissions.
Oh, really?
Right.
That's how I get, because I got the data set from you.
Right.
Yeah. Cool.
And I was subject matter expert in our midst, I guess.
I'd like to point out too that we have a wonderful resource here with Greg. Greg and I are the ones who published this data set, but Greg's the one who goes back. I guess what was this now? 40 years of CDAC?
It's a long time. No, Matt and I worked together for a couple of years, and he thought I might be interested to see what creative genius can do with the data set.
Oh yeah.
I've been working on this data since 1984 or something like that.
Good.
This is a luxury to be on the call with people like you because, like I did a dashboard. I don't know the material very well. Adam and I had a few questions back and forth, but having people who really know this material is so good.
Agreed.
We made some bad assumptions or whatever. You guys can steer us straight.
Yep. Well said, Mike. Thank you for joining, Greg. We hope we are able to impress you. Let us see. Okay, who wants to get started?
I can
Becky,
go.
Okay.
Yeah,
Becky,
go ahead, Becky.
Wait too.
No, Becky, go ahead. You want to share your screen or should I share?
You want to share? How does this work for?
It depends on you. Some people are like, I want to share from my screen because I have it on my local computer. I'll share it. If you have it online somewhere, I can give me the link and I'll share it. Whatever you prefer.
I'll give you a link. If you want a link to it.
Yeah.
Let's see. Got it hosted here on. Let's see. On GitHub. So let's see if I can get this link here.
Is this an app or a graph?
It's a Jupyter notebook.
Okay.
And it's got graphs. So here, let's see if I can go back here, and then if I want to share, I'll just put it in chat. Yeah.
Okay, so I will. let me see. Okay, I clicked on it, but I won't be able. Oh, okay. So you have three graphs there. I can share screen.
Yeah, so they're like, so there's the code at the top and then the graphs at
Perfect.
the bottom.
Let me share a screen. Let me share.
So yeah, it was
screen.
fun to get this data set because this is such a timely issue, and it had such a long expanse of time.
Yeah.
And then, so I started out with just doing the Sankey graph showing the
This one?
yeah, so the emissions growing over time, going like, so I just started that one in 1955, and I actually have one where I did the Sankey for all of the different types of emissions, because there were like 7 of them, but then I just settled on the first one. So, you can clearly see, I was just looking like a visual, and then I just compared it to, I got a hold of another data set that's temperature anomalies, and it was about the same time span. They had it going back to 1800 somewhere. So I compared those, and then like looking for a correlation between temperature anomaly and lots of emissions. And then I just did the correlation on the scatter plot and got a coefficient 0.91. So clearly, you don't know what's causing what with correlation, but you can see that as both of these things are increasing over time together. So yeah, what I did there is the colors are the different centuries. So the blue, I took something from the 1800, I think it was 1850s is when it started for one of the graphs. So I matched them up. I used a merge to bring them together on years. And then I just, then it shows the full 1900s and then the 2000s up to 2021. So you just kind of see it growing, and certainly more in this current century.
Becky, you said the coefficient was 0.91?
Yeah. So
Was that for every? I'm assuming it's for all the data here.
Yes.
Did you find, we might not have done this, I don't know if it even makes sense to do this, but did you find there was a stronger coefficient for the 2000s as opposed to the 21st century as opposed to the 20th century?
I didn't do it. I just did the full coefficient for the whole period, but that would probably be a good thing to look at because it probably is growing, more. Yeah. I mean, in the beginning, like in the early part of the data, both with the temperature anomaly and with the carbon emission, it was actually pretty low, I don't know, especially the anomaly. The temperature anomalies were negative in the beginning, almost like it was getting colder. But then, it definitely got a lot warmer in this century. So.
All right, really nice graphs, folks. What do you think? Any feedback? Any questions?
I'll just say real quick, this is fantastic. I like that a lot. The linearity there is startling, and just how, like, you see there in the 1800s, it almost entirely below zero and just goes straight up.
Yeah, I was when I saw it, when it just popped up, I was like, wow, there is. Yeah, definitely, it's happening together. Hard to deny the data, the facts of the data.
Yeah, right. Global warming is real.
Yeah.
I mean, but they speak for Becky. Where'd you get the temperature data, though? I didn't see that.
If you look at the code, scroll up. I pulled that from NOAA, and I basically posted it on my GitHub. So they have a page where you can put in some details, and then you can download a CSV. So I just downloaded it and then posted it here. But yeah, you can look at that data.
I see. That's really good work. I'll show you later. I also did some correlation plots, but not with temperature because I just used the data set provided. But the correlation with temperature is really, I think, probably the most important one. So.
There's one more now I think that I've been reading about is sea level. They've been measuring sea level, and that's another because the glaciers are melting and but
a lot of us live close to sea level, I believe. I know Adam does, and I do. I'm in the San Jose area, but that's
I do, and I'm afraid if there's a correlation between the number of years that pass and the higher grounds that I seek, because it's
Yeah,
I don't believe it.
Adam, we look forward to you hosting Figure Friday from the Catskills.
Yes, I'll do it from the mountains, maybe in North Carolina as well. Yeah, it's it would be interesting to see that correlation, definitely. Greg, you and Matt, you guys in the field, do you see as strong a correlation with the measurement of sea levels and emissions?
Greg, would you like to speak to it, or I can? It's up to you.
I think Greg, can you hear us?
I can, yes.
Would you like to speak to that, or would you like me to?
I'd be glad to have you, man. I'm just impressed that it's set up in a way to calculate that 0.91 correlation. And that's pretty impressive.
It is.
Oh, it's just I just pulled that one out of it's like a one-line statement in the code.
Yeah, but the graph is plotted just the decadal data, the series of flags. It's very cool.
Yeah, thank you, Greg. And Matt, what do you think about that correlation?
Yeah, you see a lot of correlations because, fossil fuel emissions have been rising for the last ever since we started doing it. And with a couple of exceptions, 2020, they went down because of COVID. But then, of course, they popped right back up.
Yeah.
But we see a lot of other things rising. So we see a lot of correlations with that. Sea level rise is one thing. If you go, I think recently I was browsing the climate change Wikipedia page, because I was like, what, if I didn't know anything about this and I wanted some information, the first thing I'm going to do is I'm going to Google climate change and click on that Wikipedia. Yeah. And I scroll down and there is just thing after thing, like extreme weather events, billion-dollar disasters, just over and over. And it's just straight up and so it'd be correlated because so are carbon emissions.
Yeah.
And it's scary to think. I just somewhere read in the news that we might even see a year where the average hits above 2% Celsius, or 2% Celsius above the pre-industrial average degree by like 2030 or 2035. Nobody thought it would be so fast. So it's kind of scary to see all that.
Yeah.
The other comment I would make, Becky, is more a social comment, but there's so much disinformation in the world. Is climate change is real, or is it a hoax? What's really going on? For a lot of people, that's not an obvious question. You can back this up with real data. I don't think there could be a more credible explanation of it. It's a good data set, well presented. You could probably go out in the street and find 5 people who would say, that's just a lie from communist China or the Democrats or whoever it is, right? But I think this world needs a little bit more data-driven explanations like this.
Yeah, that's why that data set on emissions is really great, because it has like I said, 7 types, and they do vary. Like I did create one where I just did Sankey for each one of them, and they are all different. But then I just picked this kind of bigger one. But yeah, the correlation, like when you learn it in school, they tell you, well, it doesn't tell you what causes with what, it just shows.
Sure.
Sure. Yeah. But yeah, it is. It is having real data makes a big difference.
And this is really good code, Becky. Very nice. You have some good experience with Plotly.
This was really good, and I'm kind of learning Dash too. So
okay.
I think these are really valuable skills. I've worked with Power BI and I don't really like it. It's like trying to learn the UI and trying to filter. Yeah. It's much better. I'm more of a software developer to just use code. So yeah, it's fun to play with.
You feel free to ask us if you have any questions about Dash on the forum.
I got two questions about this on your community, and they both got answered.
Good.
So, yeah.
Good. Who else just joined us? Jeff, welcome. Thank you for joining. All right, folks. Becky, thank you so much for presenting your code and the cool data sets with the graphs, and for going above and beyond and getting your own data set from like the temperature data and adding that. That's pretty. It's pretty cool to see what you built with it. Okay. Let me stop share. Who wants to share next?
I'll go, Adam.
Go ahead, Mike.
Okay. Share screen. Okay. Can you see my screen yet?
No, not yet. Let me load it.
Here we go. I think it should be. I think I got it now. Do you have to unshare something?
I did unshare. Try sharing again.
The share button seems dead.
Oh, there we go. Okay. No, that's not you. That's Rishi.
Okay.
Yes.
Share screen.
Hey, Rishi, how's it going?
Yeah, going good.
We're waiting for Mike is going to share.
Okay, I got it. I think I got it.
Snap.
Are you
One
seeing it
second.
now?
Well, we see. Okay, we see. I'm going to share screen. We see us. Okay, make the Mike make the graph full page so we just see that because it is small.
Okay.
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 Oof.
It's
Is there
kind of
any way
wide.
to make it bigger because it is very wide? I don't really see it very well. Oh, there we go. That's better.
Oh yeah.
Okay. So this, by the way, I've been using Plotly visualizations for about 5 years now, mostly just the open source, and I'm just kind of a newbie on dashboard development. So this is the most extensive dashboard I've made. So I broke this down into 3 areas, and I'll just go through them really quickly. The top one is just plotting the data for each value. I renamed the fields a little bit to convenient short names, but what this does is, let's start with a line plot. You can choose line or area, and this is just the raw data plotted by year. And then this one is the year over year result. It's kind of like the first derivative of the data on the left. And I can change the type to area where it just stacks them. And you can see some of the values are negative, meaning that, they were dropping. But if I go by decade, this gives you a little bit more of the trend. And Adam, this is what kind of we were talking about online here. From the area plot, it looks like there's a big dip.
Yeah, it did. It looks like there was a decrease.
And it's actually not really a decrease, because to be decreased, the incremental value would have to go below 0.
Okay.
So what the dip really means is that the slope reduced.
Okay.
Right. It started growing at a lower rate, I guess it were. But a notable point is that in the 1960s, the air in New York City was horrible. Same with Los Angeles. I grew up in upstate New York. We had just a horribly polluted Hudson River. And in Cleveland, somebody famously threw a lit cigarette into the river and it started on fire. Our environment was in really bad shape in the 1960s. There was legislation in the early 70s for environmental control. Earth Day started. So I would surmise that a lot of this had to do with maybe society waking up a little bit. Okay. And even though they didn't really reduce pollution on a decade by decade basis, they kind of slowed the decline a bit. And so that's kind of a little bit of playing around on this, just the raw data. Below that, I did a correlation setup where you can pick the X and Y axis component of these fields, and you can get the correlation. Now, when you pick the same parameter for X and Y, obviously everything lies along a perfect line and you get ideal correlation stats. But if you compare some of these parameters against each other, the flaring seems to be the most outlier-ish parameter. It doesn't really correlate with anything like fossil fuel versus gas. Goes like this. It gives you I use the Pearson R² for the correlation term with Skippy stats lingress command. I don't know how you did it, Becky, but that's what I did. And then on the bottom, I just kind of displayed this table as a -AG table. And I made this little card to give you the definition of each column because originally the headers were named by the long description, right? That's not really convenient for a column title. So I wrapped them up in a dictionary, just use this short term in the table, and then put a definition in here. And a cool thing I just learned was how to, I don't know if you can see this, but I've got these tooltips on the Dash HE table
Nice.
grid. So where I'm at with this is I'm going to continue working on this board. Like this stats table is kind of sloppy. The numbers aren't lining up. I need to kind of get that under control. I wrapped everything in a Dash Mantine container, but I didn't use any Dash Mantine components. So I want to experiment with those a little bit. Adam, and a question for you. My impression is that Dash Mantine is more of a niche package. If you were to consider like what percentage of people would use Dash Bootstrap versus Dash Mantine, I sense that most people are on Bootstrap, and that's cool to me. But
it's hard to say. I would sense the same thing because if you go to just PyPy stats and you look at how many you put the Dash Bootstrap components in there, you will see that there is more downloads in Dash Bootstrap components than Dash Mantine. That said, take in consideration that PyPy stats does every time you do a pip install, it's not unique. 1 million downloads doesn't necessarily mean 1 million people. It could mean that one company, one person using it multiple times. That's one thing. The second thing is, from what I see on the community with Dashboard being built, most community members I see are using slightly more than 50% are using, I would say, Dash DMC, Dash Mantic components, as opposed to Dash Bootstrap. Both are really good libraries, very powerful libraries. Maybe because there's a strong Discord community for Dash Mantic community on Discord, there is more of a usage there, at least in the Plotly community. But yeah.
Okay. And one into some of you newcomers here, you probably all know this, but knowing the difference between Plotly Express and Plotly Graph Objects is important. I mean, I do everything I can in Plotly Express and then go to Graph Objects when I need to tweak something, because when you do a Plotly Express visualization, the figure it returns is a Graph Objects class, so you can do some good customizations. And I always use the template called Simple White or Plotly White. I like the simple appearance of the white screen. And the default template from Plotly looks similar to Seaborn. It's okay. It's not my cup of tea, but I like to have clean, uncluttered graphs as much as possible. But it's really nice to see you new guys on the call, and I hope you guys will be back often.
Thank you, Mike. Mike, which ones here that are what you're sharing right now? Which ones don't have a very strong correlation?
Okay, usually it's anything with the flaring. You see how that is going, and why is that? Let's look at one thing. Go back to do a line plot by year, and just look at the flaring. And the reason you don't have a correlation is because it's kind of up and down and up and down.
What is do you know what exactly is flaring?
I can just give you this definition, which isn't much, but carbon emissions from gas flaring. There's nothing like using the term you're defining in the definition. But I digress.
It's gas. I guess we know it's related to gas. I'm assuming it's natural gas. Matt, do you know can you shine more light on what flaring means?
Yeah, during the production of natural gas, and I'm not sure, but possibly other things. I'm pretty sure, though, that these numbers are based purely on natural gas flaring and venting. It's flaring is when it's basically just being burned, just there at the production plant and straight to the atmosphere.
I think he's.
And also, they include vents where it's not even burned; they just dump it into the atmosphere.
But why would you burn the gas that you're trying to extract?
Because you're making too much of it.
Oh.
Yeah.
I think he's made a revelation in the data here. The raw data initially all comes from the United Nations Statistics Office in New York, and the flaring has no economic value. So is just not monitored as carefully everywhere. Some of it occurs in the field. If you have an oil well and your gas coming off, you have no way to sell the gas. There's not enough to sell. You're distant. You can capture the liquid, but the gas, you just let it go. Or it was Matt was at a refinery. You're trying to divide the petroleum into different components, and sometimes there's just no market or no easy market for the gas, so you just let it go.
Oh, wow.
There's no economic value there, so the accounting is not as good as for the other components.
Oh, I see.
That makes sense. That makes a lot of sense.
And his graph reveals problems.
Yeah, and almost with every flaring and anything else gives you not a beautiful correlation. I guess I would say unscientifically, but I really enjoyed just playing around with these radio buttons, and obviously I need to clean up, put some space between the label and the button, but this is really cool. I'm very much a newcomer to making dashboards like this.
And you will like, Mike, you're going to like the Ashman components. There's a lot of things that make it easy to style and to move the layout around.
I think I have some redundancies in my code when I run this code, and this is a VS Code, and it fires off so many instances of Python. I don't know what's going on, but I think I have some. If I just run it from scratch, see it. Usually expect to just see one of these when you run something once. So I don't know exactly what's going on there, but I will figure that out.
Yeah, I think I have a idea about that, Mike. Let me connect with you afterwards.
Okay. Oh, yeah, I appreciate it. Yeah, that would be good to know.
All right. Thank you, Mike.
And my code is posted on the community. I do pretty much everything in Polars, so if you're interested in seeing that, I'm not using Pandas much anymore.
Yeah.
Where do you find that? Where would you find that? And I don't know enough about where to look.
What, Becky, the code?
Yeah. And then
Okay. On the community page.
Let me share, Mike. Let me share with you. I can share a screen.
Yeah.
I mean, this is good because I didn't share a screen.
I stopped sharing. Okay.
Yeah, you stop. So, Becky, this is the. Have you seen this post yet?
Oh no.
Okay.
I haven't,
So this is a post where I'll also mention it on Discord, but if you go to the forum, which is just community.poly.com, let's go to the main page, community.poly.com. You can just search, let's say, Figure Friday. Right?
Okay.
And you will also you'll see the most, well, here you see a lot, but you can go to the tag here, Becky, like Figure Friday, and the top ones will be the most recent ones. So the most recent is the week 21 of Figure Friday tag, and here's everything that people post. So,
that's great. Yeah.
Everything, and you can learn from the code and how people do it. Now here's Mike's code and graph. He put some images there, and here's his code. So you can just use the click button here. You can copy everything.
Okay.
And Becky, so now that you know about this, feel free to put yours here. Just put reply here at the very end, and just share your app with your code.
Okay. Yeah, that's really cool. Yeah.
Cool. All right. Who else has something they want to show us from what they created this week? I know more people created stuff, so don't be shy.
I can share if you want.
Yeah. All right, Ishi. Are you sharing screen or am I sharing screen?
I can share. No worries.
Okay.
Nice background there, Ishi.
Yeah. You guys are sitting next to each other. I know it.
Yeah.
Oh yeah, look at that.
Both play the piano.
Both.
Need to learn that.
What a
All right. Should we see the screen? Carbon emission analysis.
Yeah. My approach was just to look at the Excel file and from the whole nation. So first thing is, I'm not sure why this country color is a bit off.
Okay.
I need to check that. The idea is that you can pick, let's say, right now it's that, 1 second. Yeah, so you can pick a country, let's say 10 years, 20 years, 30, 40, 50, custom date range, like you just want to look, click here, your graph will get changed. And if you want a custom range, like particular year gap you're looking into, and you can get into the carbon emission from that particular country. The first is, so again, from the year till the last year, you can also get a percentage change from the previous year. So 7.6% change from the previous year. So let's say 2016 minus 1.89 from the previous year. So reduced, as simple as that. After this, it's more like which one are you interested? Solid, liquid, gas. Which carbon emission are you more interested into? So let's say that I only want to look into the liquid part, and you can focus right over here. The last time I did was if it's not connected with the country in the top or a different date range, the first graph only changes. So try to connect the whole part.
Rishi, you exited the screen share.
Oh, sorry. Let me just get it again.
Okay, we see it now.
Yeah, sorry about that. Coming back down, this is like a fun part where you can enter years which you are interested into, let's say 2022, 23, 24, and so on. And there is a machine learning model running at the back end. So whenever you change over here, let's say 2025, and then do a predict, it will then run again, generate the prediction for that particular year, keeping the like some sets of parameters, and then predict it for the next year also. I do have the whole dashboard as a Docker file running at the moment, so it might be a bit slow, but it will get you the predicted values for that particular year also, and then you can compare. So yeah, that's pretty much what I was trying to do on this dataset.
I'm curious about your prediction. You said it's using AI. Is AI contributing some more factors to figure it out than just the data? Or
Sure. I can share that more about what features I have selected. Let me get that up. Where is it? Yeah, let me share that screen also.
Drop down styling. Should I say it again? Yep.
I always struggle
Yeah.
getting the drop down. Yeah.
Yeah, I agree.
So these are some of the features like solid fuel, liquid fuel, gas fuel, cement production, gas flaring, bunker fuels, and then year and nation. So these are some of the set of features I have selected. Prep the data to then only look, and then once you have that, because we didn't have much data for a particular country, so I also selected like pick those countries only and run a model only for countries which have like a 40 count, more than 40. So that's just a ballpark pick number which I just picked. So the train is more like everything less than 21. The validation is 2020. Anything which is greater than equal to 2020. So that's like I picked up the year as one of the particular feature to filter out and pick up the train, test, and validation dataset. Then just a simple random forest regressor with some estimators, let's say 100, built up and being a 4.48%, I was like pretty happy with it. Didn't go for again big.
But what is it? What is it telling us? 4.48%.
So in simple terms, it is how far it is from the error. So the actual value in 2021 versus what my model
Predicted value.
Yeah. So it's like 4.48
Oh,
far.
the
That's-
supervised training. Yeah.
Yeah.
Yeah. So pick that. Just to keep it simple, save the model as a local in the local file, and then I predicted it into the future. I mean, generated the prediction. Now the fun part was because we didn't have data for 23, 24, 25. What I did later on was use the percentage change as one feature, and then use it back again to predict it in that particular for the next year. So let's say I'm predicting for 21, and then I'll use the prediction back in the for the next set 22. I'll use the 21 year. So on and so forth.
Nice.
That's cool.
Yes.
You know what would be cool, Rishi? Can you go back to your graph for a second? Becky, did you have any other question about the code?
That's good.
Okay.
Thank you.
Let me get the graph 1 sec. It's a bit tricky to change the screen. Yep.
So what would be cool? Wait, it's loading. Okay. So first of all, what's the difference between the two yellows, the predicted trend and the predicted?
This is just to, like, if you don't want to just see the data points, whether it's going up or down,
Oh,
you can have
okay.
like the actual values.
Oh,
That's it.
okay, got it, cool.
Yeah.
Oh, that's
And
kind
if
of
you
cool.
want to see the trend, you can have
So,
it.
Rishi, you know what I'm thinking would be cool is like I'm sure this data set I guess was a little bit older, so the last year was what 2021,
Mhm.
but I'm sure there's global emissions for somewhere for 2022, 2023, probably even 2024 because we're already in May in 2025. And so if it would be cool to see your predicted lines, or you unshared, your predicted lines compared to what actually happened in
Yeah.
2022, 23, and 24. You can get that data and put it like in red there or whatever other color and see how far is it from the yellow.
Yeah. Okay.
No, that would be cool.
So
Sure,
the United Nations Energy Statistics Database is what this data is derived from. We derive
Okay.
this data from apparent consumption using fuel statistics.
Okay.
And so their record keeping actually there's a delay, there's a lag of a couple of years. What a lot of researchers do is they'll sort of project those forward with what I think is called like the World Energy Institute statistics or something. It used to be called the BP data, but they changed their name, I guess. They're still supported by BP. Anyway, a lot of people will use those BP values to sort of project these CDAC values forward a couple of years, but those are, and that tends to be a pretty good estimate. You're right. But in terms of actual hard values of inventory, that is the latest that's available for us.
Oh, okay. So there's no more. Okay. Yeah.
Sure.
For now, but here in a few months, there will be another.
Okay. Good. Good. One other thing, Rishi. I like the feature you added there. It go up a little bit where you can hide charts. I haven't seen it that much, but it's kind of cool to know that if you do not want to hide to see a certain chart, you can hide it. For me, usually, Rishi, when I look at dashboards or front-end user interfaces, I might want to have one chart a lot bigger, right? So I'll often have a button. I would appreciate to have a button, or like you have a radio button checkbox that I can click on, and it opens up either the whole screen or a modal. So it's a lot bigger. That I care a little bit less about because if this chart is good, then I'll probably want to have it there. I could just not look at it if I don't want to. But I thought that when you were going to hide one chart, like the middle chart would just expand, so it'll be like a lot bigger.
Yeah.
But it's pretty cool.
I was trying that, but it didn't work out much because I was more focused on the prediction part. But yeah,
Yes.
that's something I will try in the next one. Yeah.
Nice. And then go up a little bit. I want to hear what the community here has to say. This one. So Rishi chose to do, there were two options. There was a conversation about this on the Discord server. The y-axis, you see here the total CO2 emissions. It's from the year 2000. We're seeing about 1.5 million all the way to, I don't know, 1.4, whatever that is. Would you do the y-axis from 0 to 1.5 million, or would you do a y-axis that's just taking into account the range of the maximum and minimum data point, in which case it will be like probably 1.3 million to 1.6 million? Does anybody have a preference?
Guidance I've read on this topic, and I follow it, is that if you were doing a bar plot, you absolutely should start at 0. But if you're doing a line plot, I would say not. So I would probably just not scale it at all and let Plotly tools expand the waveform to the limits of the data. But so I wouldn't start for 0 from this line plot. But
Okay. Anybody would do it differently, or Matt?
Sort of in line with that, but for maybe slightly different reasons. You know, with an area plot or a box plot, like you said, that area from 0 up is part of the representation. Whereas with line plots, the representation is just that line, right? So I would say, like, be sure to just show all of the relevant information to express what you're trying to represent. That's sort of my guideline, I guess.
Okay. Cool.
there's a good book that inspired me for all this work. It's called Storytelling with Data. Covers this really well. Very easy read. I would recommend getting that. In fact, I have it at my local library in San Jose. You can probably get it for free.
Thank you, Mike. Yeah, Rishi, I would do the same thing. Like when I was having this conversation with you, I think it was Marianne and others on the Discord. What the last thing that I said, what I actually meant was, not going from 0, just so we can see, going from, like, even if it's the either maximum to minimum data point of the data set, or you can just range it from, like, let's say 1.1 to 1.6, right? 1 million to 1.6, because it would be easier to see. It would be easier to see the difference between the years if the line chart, if the range is a little bit more restricted. And so let's say it's from 1.3 to 1.5. That dip in 2020 would be very visible, very evident. Now, Marianne had a good point. Like, this could be, like, tricky. It could be a bit misleading, because if you compare it, like, to total absolute numbers to 0, it's not that big of a difference. And I agree with her, in which case, that's why I recommended adding, like you did, Rishi, hover points, right? Hover data, right? So it looks maybe 2020 because all you see is really the line between 1 million to 1.5. And in 2020, you'll see like a big dip, right? From the maximum y-axis to the minimum y-axis. But you hover over and you see it's only 10% or whatever that is. So they don't think it's like 100% dip. Cool. All right.
Makes sense.
I will say too, I do, just as an observer, a reader of charts, I do feel a little like I'm being duped when I look at something and there's a whole bunch of missing y-axis, just for a split second, even if there's a good reason.
Yeah.
So I don't know. I mean, I also like that little squiggly that sometimes sort of indicates, hey, this is a truncated y-axis. But anyway.
Yeah, no, I think you're right, Mike. Like in theory, let's put this in practice. Like, if it's, you don't want to create a chart where people feel duped. Like, wait, this is I have to go over the hover data, or I have to read to understand. No, this is actually not the case. Like, you want the visualization to be more or less equivalent to what the percentages in this case, the differences in this case. For example, if we did from 1.5 million, which I think is the maximum here, to 1.3 million, that drop in 2020 would be extreme. It would be from the very top, right, almost the very top, to the very bottom. So it would seem like almost 100% drop, right, because that's the only thing we have. But it's not. How much, Rishi? How much is it dropping 2020 percentage wise?
Minus 10.6.
Yeah, it's only 10%. So you would feel duped. You're right, Matt. If it's like just from 1.3 million to 1.5. So it is important to find like the middle ground where you don't feel, nobody feels cheated or duped or misled, but it's clear to see that there is a difference between the years.
On that point, Adam, I would also say if you just auto scale this to get the full dynamic range of the plot dimensions, I would probably make the labels a little bit larger, just so that people should be drawn to the y-axis, so they know that they're not looking at a 0 to whatever.
Yeah.
Okay.
Yeah, that's a good point.
Yeah. My thinking was, because these numbers are in million, and therefore, like what you have mentioned, Adam, that percentage change is really like very nominal, and just to give a rough idea that okay, it should be up, down, and the best way possible was to just keep it from 0 to the maximum. So I think that was my
Logic. Okay. Yeah. Okay. Cool. Okay, Rishi, thank you for showing us your app. Getting better and better with your Dash apps.
I tried with the idea of using a log scale for this stuff, but I didn't do it. But I don't know if that makes sense for the y-axis. Some of the stuff. But
I don't think it would work in this case, Mike. I don't think it would work. My sense it would, because log scale is usually good when there's extreme value like jumps.
Yeah.
I think it wouldn't make a difference. All right, we have time for one more presentation or showcase of an app or a graph. Does anybody want to show something? All right. Well, I guess we're set for the day.
I mean, I could show one thing if nobody
Yeah,
else.
go ahead, Matt.
Sure. Let me see here. I'll click present. Okay. Share. I don't want to share my whole screen. How does this work?
Matt, do you have that figure of the Soviet Union?
No, that was somebody in the Discord community, and I'm not sure who it was. But when I emailed Greg and said, "Hey, you should come check out Figure Friday this Friday," I had sent him the plot somebody made on the Discord where it had the USSR and then it split up into its constituents.
Oh, let me see. It's right here. Let me share screen for a sec. 1 second. Share. Greg, are you talking about? Are you talking about this one right here?
Yes. I think that's you don't want to use that because two of the parts are missing, but it's a very powerful story about what happened with the breakup of the Soviet Union.
Oh. Right, yeah. USSR. Marianne, I think, Marianne posted this. So it was up until when did the breakup with the wall fell? 1991, I think. And then
that's right.
and then it became Russian Federation. Well, today's known Russia, and the rest are what used to belong to the USSR. Nice.
It has this powerful side story to me. The breakup, the problems that are going on now in the Ukraine, you don't know until you see a graph like this that Ukraine is in fact the second biggest part.
Yeah, I was looking at that too.
Well,
Like, what's the top line? Like, how did they pick who to attack first?
Oh, boy.
Yeah, that is true. The purple one, you're right. Interesting. Okay.
That's a very cool plot.
Ukraine is the only country there that was part of the Soviet Union before, I think.
I think they were all of them, Mike, part of the
Yeah.
Soviet Union.
Armenia also. Well, that was a long time ago. Estonia, they fell off first. Estonia.
No, they were all considered part of the USSR.
That all came apart in 1991, as shown here in this graph.
Yeah. Okay. Yeah. Sorry.
I think
They
so.
are.
Yeah, if
Or
you find
different
any
time periods.
different data, let us know. Matt, you wanted to show your graph?
Sure, I'll share something real quick. It's not a dashboard. It's just a plot. Greg and I, at some point, I lose track of time entirely. This could have been a year ago. It could have been 3 years ago. We published a paper. I'll send a link to it here in a
Could
spring.
have been yesterday, Matt.
I'm sorry.
Could have been yesterday.
Could have been. I really have no idea. This is if you wouldn't mind sharing this. I guess they post the date that it was published on
Oh,
the.
let me see. Okay, wait. I'm going to share this on screen.
And it's on page. It's their page 56. It's the PDF's page 7.
Okay, let me make this just a little bit bigger so people can see. This you said page 7?
Right, and they're at the bottom. And I'd share this on the Discord community. But this is maybe one of my favorite plots I've made with this data. So on the bottom half, the top half is of course a time series, and along that time series we have these dotted lines, and those represent those sort of magenta-ish, pinkish labels down there on the ternary diagram on the bottom half. That bottom half there is a ternary diagram. So what that represents is percentages. Any given point on a ternary diagram represents the percentage gas, percentage solid, and percentage liquid of total emissions. So you can see starting there in 1885, before 1885, all emissions from fossil fuels were solid, coal.
Okay.
But there in 1885, you started to get some other uses. Actually, I think I might be misspeaking there a little bit. It wasn't until 1885 that all three had values. That's why I started at 1885.
Okay.
But so you can see it moving up there right up to 1938, and then
Matt, I'm sorry. So what is the blue line represent here? The blue line represents gas, liquid, and solid together?
So that is a time series over time. It starts there at 1885 and it goes to 2020, and it shows the progression over time of the mix of where emissions are coming from. There in that corner, in the far corner there, is almost completely solid. If you were there at that corner, you'd be 100% of your emissions coming from solid fuels.
Okay.
If you're up at the top corner, then 100% of your emissions come from gas fuels. And if you're at the lower right corner, 100% of your emissions come from liquid fuels. So if you're in the center of that diagram, it's 33.3%.
So let's just take one example for a second. Right here, 1973. So what percent comes from the right side is liquid?
Yeah, going down to the bottom right is liquid. So that's going to be about 50% liquid. You can see these lines are the ones measuring how far we are from that 100% liquid corner.
Okay. Okay.
So that would be about 50% liquid. And then looking at these lines that measure how far we are from that solid, 100% solid corner, that tells us that we are between 30 and 40, about 36% of the emissions in the world in 1973 were from solid fuels.
Down right here?
That 1973 there.
Yeah. Okay.
Right. It's between 40 and 30% on the solid axis.
Yeah.
And then with the gas axis is the easiest to read because it just goes straight up and down. And so over time, we see just a steady increase of the percentage of world emissions coming from gas. And that's better. I hesitate to say good. One of the key considerations and why this plot is so important is you have different efficiencies of energy from a given amount of carbon emissions. Put differently, I can get more energy. How should I say this? Okay, let's do the same amount of energy. Okay, I have some given amount of energy, If I get it from solid fuels, I release more carbon emissions than if I get it from liquid fuels.
Okay.
And if I get it from liquid fuels, I emit more carbon emissions than if I got that energy from gas fuels.
Okay.
And it's about a 5-4-3 ratio of the efficiency. So we want to replace solid fuels with gas fuels as much as possible. That is part of mitigation and adaptation strategies for climate change.
Okay.
And so I really love this plot because you can see World War II and how that changed everything. You can see the 1973 and the 1970s oil crisis and how we very quickly moved away from using liquid fuels. You can see the 1986 oil glut. 1999 is significant because you start to see a significant rise in emissions from China and Asia Pacific. And then 2011 is when those emissions that were rising from China start to level off. So they don't start going down, but they start to level off.
Yeah. I
Right.
see.
And then 2020, there's like a quick jump away from liquid fuels because we weren't using as many liquid fuels in 2020.
Man, I'm sorry, but what I'm a little bit still confused on is maybe it's this, but so this is, I'm looking at the ternary plot right here, right? The bottom part will present the solid.
No, the solid axis is in the direction of that arrow up there. And those, the perpendicular ticks that are perpendicular to that solid axis represent, like measure what percentage of solid.
So solid will be from here down here.
Solid would be,
Because I see this is, you said the direction of the arrow is
Yes.
this way.
yeah, or what you said originally is true because that is where I have labeled it. Yes. So that 100%, 80%, 60%, 40% down there at the bottom, that's labeling how far away from the 100% solid fuel corner you are.
Right. So this will be the bottom will be solid. So if a point is on the bottom here is at 100, this will be 100%. If a point is here is at 0% solid.
It would be 0% solid and 0% gas.
Right.
It would be 100% liquid at that corner.
Okay.
It's a bit to wrap your head around, but it's one to look at. I really enjoy this plot, and it was made with Plotly. But what I did is I exported as a SVG and put that into Illustrator.
Nice.
Matt, that's a brilliant work. In this forum, we're often looking at like how could this plot be made better, appearance, all those kind of things, right? I absolutely paid zero attention to that when you were presenting it. I was listening to your story and learning from it. It was so well done. Great
Thank
job.
you.
And that's how it should be, by the way. When you present a slide, I'm guilty of this all the time, but somebody's presenting something, they're trying to give me a message, and I'm saying like, why the hell they have the grid lines on, or why they don't make this more readable, that more readable.
Yeah.
That's when you need to improve your slide creation. But what you did was brilliant and good explanation. It's so nice to have you guys on here who know this material very, very well.
Well, thank y'all, and thank you, Adam, for using this data set. This was really awesome, and thank everybody. Thank y'all for This is so cool to see all these. This is
Of course.
cool.
No, it's fun. It's good to play with.
All right, folks, at the top of the hour, thank you, Greg, for joining us and looking at what we can build. Thumbs up. And Matt, thank you for the data set. And Becky, welcome to the community. I hope you to see some of your posts on the forum, and maybe you can join on the next Figure Friday as well. The next Figure Friday, I'm going to post today in about an hour or so. It's more of a fun-ish, like about movies, entertainment, Hollywood kind of Figure Friday. And I'm going to release a Plotly challenge today. Plotly challenge are released once every 2 months or so, and it's usually around building challenging the community to build a beautiful Dash app. In this case, we're doing something a little bit different. It's going to be focused on building Dash hooks, Dash plugins. But I share all the documentation there in the post that I'm going to publish soon. But it's a way to make it a lot easier for people to update their Dash apps in their Dash ecosystem based on plugins that people build. I can build a plugin that updates the title of a Dash app no matter where you are, which Dash app you have, right? So I put it on, I install it, publish it on PyPy, and then you grab it from PyPy, you do pip install Adam's app title or whatever, and then you can using that hook, you can easily update your app's title. Not the best example here because you can easily update an app title inside your code. You can just change one line, right? But there are things that are a lot more sophisticated than just changing an app title. Maybe you want to change a layout. Maybe you want to change a grid. Well, you can build a plugin to help people do that through a function which is just to state what they want, and it will just automatically do that. I have a demo of building a function that shows errors on the Dash app, so it's a lot easier to cache the errors. So it is a more sophisticated topic, but it's interesting to learn from. So I'm going to post that later today. For the next month, people have an opportunity to participate in the challenge. But in addition to that, we will continue having our, of course, our Figure Fridays and data sets that we create. I think that's it. Everyone, thank you for joining us. Mike, if you want to stay, Mike Bertel, if you want to stay a minute here, I want to show you something about your code.
Thank you so much. I'm here, Adam. Let me pull this up, but yeah.
Okay.
Thank you.
Stream.
Thank y'all again.